Hi, my name is Noah Gift, and today we're going to talk about one of the more core components of Python, the business logic, right? The function that allows you to do anything really in the Python language. And I think a lot of times it's easy to think about concurrency, object-oriented programming, to get into a web framework or some other tool or deep learning and forget that the core or the center of what happens in programming is a function. Especially with cloud computing, really there's an input where you have, let's say, an X and a Y. You do something like, let's say, add two numbers together, and then you return back a value. That core concept of taking a unit of work and doing something and returning it back is at the center of some of the things that we're going to cover in the next several hours. So stay tuned. We're going to cover how to use a Python function to do pretty much anything: cloud computing, distributed computing, deep learning, web frameworks, command line tools, also GPU programming. And then from there, you can actually take those aspects of mastering functions and then move on to building microservices yourself. I'm going to make a new notebook. So I'm going to go here, say File, New Notebook, and we'll just start from the beginning here and actually start to use this to master the skills of Python. So the first thing I'm going to do is we'll call this statements, right? So I'm going to name this particular notebook something, and this is a good idea for you when you're practicing things, is to potentially create a new Collab Notebook for each thing that you're working on. And what I also can do when I'm done with this is I'll share it with other people. And in fact, one of the things that you can do that's pretty cool, and might as well just start with this, is I'm going to make a new repository in GitHub. So I'm going to go through here and we'll say Python functions, and we'll say 923, just like that. And if I go into this description here, I can put some information about what it is we're building. Say this is a new repo for a live training by O'Reilly. All right. And what I like to do when I'm working with Python code is create a README file so it's easy to put information out there for other people. And this is a pretty critical one as well, as to add a git ignore so that inside of your project you can ignore things that show up commonly with Python that you don't want to check in, like a .pyc file, for example. You don't want to check those in, or a virtual environment. And then we can just say create repo. So there we go. So I'm going to go ahead and share this out here. And so what's cool about, once you start to get this workflow set up and you're using Collab here to kind of play around and test your knowledge, is that I can go to this, I can say File, save a copy in GitHub, and it'll say, okay, you're blocked. So I just need to look at the pop-up, and we'll retry it again. There we go. And then it'll give me this dialog box. And I can't recommend this enough for you as you're learning Python, is to have this workflow of you go to Collab, you start to make notebooks that you're actually demonstrating potentially a key piece of knowledge: statements, functions, microservices, loops, or whatever it is. And you can go back and actually execute your history. So it's really like a training ground. And so if we go back here, I can look at this Python functions repo that I just created. I have hundreds of repos, so it takes a little bit to find the right repo. Where was it? Was it Python functions? I think I called this. Here we go, Python functions 923. And then notice that I'm going to save it into the main branch, and then it's going to automatically keep the name statements here. And then also it can include a link to Collaboratory, right? So that's exactly what I want. There we go. And then it just checks it in. And so what's neat about this is, as I kind of go through here step by step, I can put checkpoints in, and then other people can execute it. So if I go here, anybody in the world can just go take a look at it, and they can start running my code. Now there's nothing here yet, so we need to start putting some things in here. So the first thing I would start out with this Collab environment is to create a little bit of a structure so it'll be easy for other people to see what's happening in this notebook and to navigate around. And then also for me, if later I want to come back and I want to try some stuff out. So here we go. I'm going to say next, and I'm going to do two hashtags here in this cell. So notice there's two types of cells. There's a code cell, which we'll use quite a bit, and there's a text cell. The text cell is for adding notes or adding a hierarchy. And the hierarchy works basically with how many hashtags. So we'll put a couple here and we'll just say statements, right? And if I click return, it shows that this is now a dialog box that I can kind of hide, right? Which is pretty neat. And then what I also could do is I can make another text cell here and use this up arrow, go up, and we can just say like lesson 1 or something. Lesson 1 statements, and then I could actually put a single hashtag and do a shift return. And then what's neat about this is if I collapse it, it collapses everything. So I can create this hierarchy as I'm learning things and I'm playing around with this code. And then if I go to this table of contents, there we go. We can see that actually it's a nested hierarchy. So in my opinion, one of the best ways to study Python, be an expert on Python, is this workflow that we're just going through here. And notice I can actually give other people this code as well, and I'll show you in just a second. So if I go here and I say prints, and we just do hello world, which is the typical way people will introduce others to Python. Here we go. We can see it. We've got our hello world program running. And what's great about this is that I can now share it with other people. So I can go here, I can say file, save a copy in GitHub, and then it'll go back to that notebook. Now it is a little bit annoying that it doesn't remember that, but hopefully you don't have to make that many changes back and forth. But let's see here, we'll go to Python functions, perfect. And now we can see that other people can go into this repo whenever they want, and they can just click this button. Here we go. There, and then I can just run this notebook, and it says run anyway. This just says that somebody else created it other than Google, so be careful. So in a nutshell, this is, I think, a great place to start with Python. Is where can I run my code, and where's a way I can keep track of my progress and make it really easy to go back and forth. And so I think that this is invaluable for learning Python. And so let's take a look at this real quick and see why does this work and what does it actually do. So if you notice here, if I hover over this, it says print, which is a built-in function. And so Python has a bunch of functions that are built in, and print is something that allows you to print out text. And a function has an input, here we go, and it has something it does, and then it has an output. So in this particular example, the input is a string, and it says hello world. Notice that I also, if I wanted to get a little bit fancy, I could even do a template. And so let's say I create a variable. And so in Python, to create a variable, you would go through here and just put any kind of a letter together and say, let's just use the word apple, and that's a variable. And then if I want to use that variable in a print statement, I can say prints, and I can use a fancy thing called an F string and say this is a good fruit to eat in the winter. And then I can put in these brackets here, these curly brackets, and then substitute it out. So really, this again starts to use the power of both statements and functions, because the print is a built-in function, but the statement is what is actually being run. And so all I do to use that variable is I put it inside of these curly brackets, and I also have the F at the beginning. And if we do a shift return, you can say this is a good fruit to eat, and notice that it actually substitutes that out. So just this right here, I think, is one of the more useful aspects of starting to know Python, is know how print statements work, use them in Collab Notebook, know how variables work, which is really pretty simple. You use some kind of word, it could be any word, you make equal, and then you put it inside of a string here. Now, you also can do other kinds of variables. So this is a string variable, but let's say we wanted to do a number. And so let's just say number, and I put in 100, right? So we've got now a different type of variable. And how do I know what it is? Like, what's the difference between a string or, in this case, this is an integer? Well, fortunately, it's very easy to play around with this and learn what's happening inside of Collab. In this particular example here, notice again, I can hover over it and look, it even tells me what it is. So that's another really awesome thing about this Collab environment, is that it will tell me what the types are of things that I'm using. Look, if I hover over this, it's gonna say it's a string, right? So that's super helpful. Another way you can find that same information is you can use another built-in function called type, and you can just put in whatever it is you want to figure out what it is and do a shift return, and then it will tell you what that type is. So this is a great way as well when you're first learning Python, and sometimes it can be confusing to know like what type is what another type, because Python doesn't have explicit typing. Normally, there are ways to do it, but in general, people don't use explicit typing that much. And so you oftentimes will need to figure out what the type is. One way to do it is hover. Another way is to use the built-in function type. So in a nutshell here, now we can do both strings in formatting and we can do numbers. So if we go to here and we say print, and I add maybe another statement with an F string and say the amount of money I like in my wallet is, and we put in the number, dollars, right? So it's gonna swap out that variable, and it'll even tell me when I hover over it, which is really helpful. There we go. The amount of money I like in my wallet is $100, right? So you can put strings inside of an F string formatting statement, and you can also put numbers inside. So this is really kind of a great way to get yourself started. So let's actually take this code and again save a copy so people at home can use this and do this checkpoint. There we go. So it's finding the repos, and we go down to Python here and then save a copy. Great, there we go. We've got the latest copy here, and you can see all those different parts. So now if I want to, it's a good spot to maybe add a little bit of structure, right? Because this maybe is not descriptive enough. So what I could do here is make another subsection here that just says print statements, and this was two hashtags. So let's make one that's 3. So we can do this, and we can say hello world examples. There we go. So now if I go to this section, look, it's got nested. This is level 1, level 2, level 3. So pretty cool again, because if you start to build out a big enough one of these notebooks, again, especially for, let's say you're studying for a programming interview, or you're learning some book, or you're going through something. I personally think these are a great way to solidify your knowledge and go back and forth and try it out. And it could get so large that you don't even know where the notebook begins and where it ends. But if you use this table of contents, it's really easy to navigate towards different sections of the notebook. And I have notebooks that have 1,000 things in them, and it really is almost impossible to use it unless you use this hierarchy. So there we go. We got the hello world examples, and even these cells can be copied from one notebook to another. So if I go here, in fact, I could actually copy. I could say, copy cells, and you could actually copy it into another notebook, which is a pretty cool concept. Okay, so we have the beginning of the statements, but what else is really important to know about inside of building statements in Python. Well, I would say the next thing that we should talk a little bit more about are potentially data structures. So if I just hide this here and put in another triple quote, and we'll say data structures. This would be a good spot to talk a little bit more about what are the different kinds of data structures. So we have a variable here, right, which we already did, right? That's a basic variable, and in fact that's pretty intuitive. But we also have things that can hold more than one thing, and in Python there's a list that can hold more than one thing. So let's just create a variable here called myList, and that's an empty list. And with a list though, you can put things inside of a list and then use them for other things. So what we could do in fact is even clean this up a little bit, and I think this was 3. Let's add a 4 here. So let's add another text cell, and we'll do 1, 2, 3, 4, and we'll just call this variables, right? And then we'll add a cell below this, and we'll call this lists, right? So we can kind of enumerate all those different copies. There we go. So we have data structures, we have variables, and we have lists. Although that shouldn't be, let's see, this is 4. Okay, yeah. So these look like they're at the right structure. So with a list, why would you care about a list? Well, you can put things inside of a list where a variable is static, right? It's just assigned to one thing. So inside of a list, I can do this. I can say my list dot, and notice now it shows you a bunch of built-in things that I can do. And that's another great feature of Collab Notebook, is that if you do dot on something, it'll tell you what are all the capabilities. So it's a little bit like if you're playing a video game and you want to figure out what are the powers of some character, you can read the manual and it'll tell you all the things it can do. It's kind of similar. If you do dot, it just shows you this whole list. And so what we want to do is append. So if we click on append, in fact, there's even a little trick you can do where if you hover over it, it'll even tell you exactly what it does. It says append object to the end of the list. Okay, well that seems pretty intuitive. Well, what happens if we put the number 1, and now I go to my list and I hover over it? What happens? It says that there's something inside the list because Collab Notebook is so smart. What happens if I put more than one thing? Okay, let's append another thing. Let's put the number 1 again, and if I then go over my list and we append it, there's 2 items inside. And so we can even do this, and we can say, how many items are inside. And what we can do is this, we can say len my list. And if I say len my list, it'll show me that there's 2 things. And if I do a print of my list, it'll show me that there's 2 things, right? And in fact, it'll show me the data structure. So that's really the purpose of a list, is to just kind of, it's like a bag. Like if you go to the grocery store, sometimes I go to the grocery store and I will just kind of grab a couple things, grab some cold brew coffee and maybe like, some fruit and maybe like a yogurt or something. And I was like, okay, I got everything I need. But then sometimes I need more than that, and then I can't hold it in my hand, so I need to get a basket, right? It's kind of the same concept, is that you need to put all this stuff inside so you can do something with it. And this is maybe the basic way that you use a list, is to like put things into it. Now, another thing you can do with a list here is, well, what if I want to add a bunch of things at once? Well, an easier way to do it would be to define things. So let's just say, many things at once. How would I do this? Well, what I could do is I could actually just define it and say another list here. And while I'm creating the list, I could do this. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And now I got a big list, that has a bunch of things inside of it. And if I say len, another list, and I can even autocomplete by using tab here, it shows me there's 10 things in a list, right? And one of the things that's cool once you have a lot of things in a list, and this is why people use them, is you can actually grab different parts of the list and do things with it. So for example, if I just want to get the things at the very beginning of the list, I could do this. I could say, let's grab maybe like a few things off the beginning. And so if I say 0 to 2, because it's indexed at 0, so this is basically the essentially row 0, row 2, row 0, row 1. So it starts at 0. You can actually grab a few things from the beginning. So we can even put a note here that says grab 2 items from the top. And then if I want to grab 2 items from the end, we can do the opposite essentially. So I can go through here, I can say another list, and then I can do -2, and let's see what happens. We want to say -2 to potentially 0. I guess that would be one way to handle it. No, wait, -2 to actually, we would want to do this. There we go. So what this one would say would be grab everything but the last 2 items from the end. And if I do this, we see -2. This should show the last 2. So basically, you can kind of play with this wherever you put this. If you do this, this would be from don't show me the last 2. And then if I move this colon, it'll say only show me the last 2, right? And then if I just do -2, it'll say just show me the thing right at direction -2. So go 2 back. So there's a lot you can do. Probably worth showing each one of those. So we have this. We're like just this item, and then if we build this again, we can do. Let's just print that out. This would be. It would probably put these on different lines actually. Let's even take this out and put things you can do, and then we'll pull this to another line, and then we'll say inside of here we'll say everything but last 2, right? And then we'll do another one that says only last 2, and then that one would be like this. There we go. Right. So just by putting that colon in different sections, we can kind of change things around and do all kinds of fun things. So this is called slicing, and slicing is a great way to use a data structure. So I can now go like this, kind of hide this, so I can work on something else. And I also can just say, again, save a copy in GitHub, and then other people can play around with this code. So to me, again, it's invaluable to be able to play around iteratively with the code, because it gives you an experience that's hard to replicate if you're just reading something, or even if you're just writing a script. It's very difficult to replicate what I just showed, which is sometimes I forget. I'm like, wait, is a colon go this way, or is it this way? Or you have to try it out and experiment with it in order to master it. So let's go to the next section here, and let's add now a different kind of data structure with it, which is a dictionary. And with dictionaries, these are really handy because they come up quite a bit. And I'll just minimize this. So a dictionary, the key reason for this is with a list, you're basically slicing, right? That's the common way that you're interacting with it. You're putting a bunch of things in, you're slicing, or you're picking it by index. So I want just this item. A dictionary is different in that it has a very fast lookup capability. And so how would I make a new dictionary? So we could say my dictionary like this, and then I could just do this. There you go. That's an empty dictionary. And then if I look at my dicts and I say dot, we get those same capabilities again, this kind of superpower that shows up that we can take a look at because of the power of Collab, right? So here we go. It says, here's all the different things that I can do, right? All the different functions and capabilities. Now, in this situation, it doesn't have anything inside of it, so there's not much that I can really do yet. So what I want to do is actually put something inside. And so I can say, once you've already created a dictionary to put something inside, you can put it as a key. So here we go. Here's one, and then we can put one like that. And so now if I say my dict and I say dot, my dict dot, we can actually look at values. And if we look at values here, and it says an object providing the values, it shows what's inside of here, right? And that's just what's the value is the right side right here. But what if I want to look at the keys? Well, I could do the same thing. If I do dot, notice it has one called keys. And if I go to keys here, right, this shows me the left side, right? So we've got keys, and I can just put a left side. And then if I go to my dict dot values, we can say the right side. There we go. And then what if I want to look at both at the same time? And how would I do this? I would say my dict dot items. And how do I know that? Well, I can actually just hover over it, and it says built-in items method. And in fact, if I even do this, I believe it'll tell us, if I do question mark, actually, that's another way you can find out more, is you say this, and notice it'll actually give you the full documentation. It says a set-like object providing a view on the D items, right? And so if I do this, we can say both. So we'll say both key and the value, like that. There we go, and now we got both. So pretty cool that you can actually just use that dot syntax to really discover your way through how to build things, and put things in one by one. Now, again, just like the list, it's pretty common to put things in it before. Like, it's less common to just make an empty dictionary. So let's actually put things into the dictionary. We'll say new dict, and then what we can do is we can actually even use our we can actually do a return, and it'll make like an empty bracket like this, and I can actually put a bunch of things inside. So if I want to say one right here, and I say one, and I can do two. Let's do this. And two, we can do three, and three. Sorry, three. Anyway, I could put a few things inside of here, do a return, and if I say new dict, I can also basically say a dot items and see what everything that's inside. There we go. And so if I want to say keys, new dict dot keys, it will only show me the left side here of these keys, right? And so the reason why people will do keys or values is that sometimes a dictionary can get very large. Like, where I see this a lot is in calling web services on the cloud, is that you'll get a dictionary back in Python, and then the payload could be, let's say, 1,000 items. And so a lot of times what you want to do first is look at the keys. So you may only care about one subsection, because again, let's look at a deeper dictionary here. So let's just say like another dict, here, let's say another dict. And inside of here, let's say I want to put like a nested structure. I can do that. I can do one, and I could even put in a list, and this could be like 1, 2, 3, 4, 5, and then another one could be 2, and then this could be like 6, 7, 8, whatever. So, and then you can even have nested dictionaries and lists. And so sometimes what happens is there's just so much stuff, it'll take your whole screen up. And so really what you want to do is actually look at the keys, and maybe one of them says something like, for example, this could be like AWS Lambda, and then this one would be like AWS S3. And so if you did a the keys here again, and you say another dict, and I said keys, you're like, I really don't want to know what's going on with, let's say, AWS Lambda, what the results are from some web service call. I only care about the AWS keys thing. So how would I do this? Well, I would just go through here, and I would go and say keys, and then at that point, that would give me the ability to just call one of those, and I can just put this in, and I can say AWS S3, right? And I can just get AWS S3 dict, another dict. Here we go, another dict. Let's get this, put this inside, and that would just give me the results from that. So that's, again, what I do quite a bit when I'm using things. And one thing to remember about a dictionary is that it's really the direct mapping for JSON. And so put a little note here is like JSON payloads get converted to Python dictionaries. And so that's why these are also really important, is that JSON stands for JavaScript Object Notation, and you're using this JSON format when you're calling web services, which is really common, and they get converted into Python, or you convert it back again to JSON. And so it is important to know how to interact with the dictionary. And again, my opinion is this style of just playing around with it is really the way to go. So the last thing that I'll cover here real quick would be to talk a little bit about control structure. So really there's not that much stuff that we need to go over to get to the beginning of Python here. So I can just go through here, and I can say control structures. And so the concept really for control structures is that, how do I do stuff with these other things here, right? So, I've got lists, I got dictionaries. So like, how do I do fancy things? Let's say I want to print everything that's inside of a list. Well, let's go ahead and take a look at how that would work. And so let's go to the traditional thing here, which is, let's look at this structure. So I got this data. Yeah, so we want this one to be a 3, and then I will do a for loop. There we go. So the for loop is kind of the classic way to play around with data structures. And so what I can do is I can just say fruit, make this into a list, and just put in a bunch of fruits, apple, and we can say pear, hopefully fruits with short names, and let's say apple, pear, and I guess an avocado is a fruit. Avocado, there we go. And now how do I actually interact with this? Well, I could create a for loop that says for, and we'll call this fruits, for fruit in fruits. And that's how it works, is basically this is a temporary loop variable, and inside of here I can do things with it. So I can say a fruit that I enjoy often is, and then I just substitute it out using the method that I talked about earlier. So I can just go through here and I can just put in fruit, right? So this is a temporary variable that's used in a loop. And once I do this, it'll loop over every single item inside. There we go. A fruit that I enjoy often is apple. A fruit that I enjoy often is pear. I would probably make that a little more English friendly here. A fruit that I enjoy often is a pear. A fruit that I enjoy often, apple. Fruit that I enjoy often is avocado. So basically, you can actually go through here and use these data structures and combine them with a loop. So that's really the core concept of statements. And there's lots of more statements that you can use. You can do, like, for example, while statements. You can do conditional statements. You can say, like, for example, for fruit in fruits, if the fruit in this particular loop is an apple, what we can just say, Prince, I love this fruit. And then we put in the fruit. And then we can also, if we want to, we can just go through and just break. Right? And so basically, notice that even though I was supposed to be looping through all of this, because I said this conditional statement, it actually went through and just said, oh, you're out. And we were able to go through here and loop through this. All right, so I'm going to go ahead and save this and go to save a copy in GitHub. All right, and then I'm going to put this in our notebook right here, or into our repo. There we go. And yeah, let's just add a quick, there's one question on adding list comprehension. We can do that real quick. Let's just 1, 2, 3, 4 list comprehension. So the main takeaway with a list comprehension is that it's just a way of doing a very fast performance loop, and that's really the gist of what a list comprehension is. And so it's basically a way of enhancing a loop. I mean, that's probably the best way to think about it. And I'm going to grab an example I've got here real quick, where I can talk about that. Just give me 1 second to pull this in. So we'll say list comprehension. Oh, and I can actually make this like maybe, yeah, there we go. Perfect. List comprehension. Here we go. And I'll just grab an example I've got. Lists. Okay, so here would be a good example of a list comprehension. If I throw this inside of here, notice that I have a list that says Sambo, Muay Thai, Brazilian Jiu-Jitsu. These are 3 kinds of martial arts. And then if I want to go through here and I say new phrases, I can actually put this into this syntax here, which is a list comprehension syntax. The reason why it's a list comprehension syntax is that I have a loop inside of these square brackets. And so what this does is says, listen, every time I loop through these items inside of here, I want you to combine these things together. So if I do this, and then I put a string below here, or a code snippet below here, I can just say new phrases, and then it'll show it out. So basically, the main takeaway here, and I think if I do this, if I say type, it should show me that basically it interprets that as a list comprehension, or as a list. And then if I do this, if I say new phrases, that interprets it as a list as well. So basically, the list comprehension here is just a backwards loop that you use to do something very, very quickly. That's really the list comprehensions in a nutshell. So let's now, I'm going to save that into GitHub, and then I'm going to now move into functions next. And so let's go ahead and save this in to here. And then let me just briefly talk about a function for a second, just the foundational components of it and why I personally think it's so important. So a function is the center of the universe with many programming languages, including Python. And inside of a function really is this concept of an input, right? So you have something that goes in, you have the work, which this would be the unit of work, and then we have the out, right? And this is basically everything that ever happens in a function follows this kind of a concept. And it maps very well to many different kinds of problems. In fact, if you think about, we can take the function here in Python and map it to different things. Well, what are things you can do with a function? Well, one of the things you can do is you can build a command line tool, which we'll get into in a little bit. You can also build a microservice, which is really popular right now. You can also do GPU programming. There's some really cool examples of doing GPU programming using, let's say, the Numba library. So you could take a Python function and tell it to go right down to a GPU and do some kind of vectorized function. You also could do a cloud function. So you could build, let's say, some kind of a distributed computing solution where you have a cloud function that responds to an event. You can also do ML, right? There's a lot of machine learning where it's just literally a function. So basically, I think the function is really one of the most useful things to know in Python. You can also do decorators, right, which we'll get into in a second. You can also do closures, is another example of things that you can do with Python. So really, it's a building block for pretty much anything you ever want to do. You can actually do it with a function. I mostly write functions. I almost never do object-oriented programming anymore. I just don't need it. But if you're using a GUI, I think that's a good reason to do object-oriented programming. But for most of the work I do, I'm in the cloud. I'm doing machine learning, DevOps stuff. So I almost never write classes for anything. So let's now move on here. And actually, I'll show you a neat little trick because we have this picture here. I'm going to make another Google Colab doc. So I'm going to say File, New Notebook, and then I'm going to call this Functions. And then we'll do the same thing we did before, right? We'll go through here and we'll build out a structure. So we'll go here and we'll just say functions like that. And one thing that I can do that's kind of cool is that you can actually embed pictures. And so if I go back to this Sketchpad picture, I'm going to do Shift Command 4 on my OS 10 machine and drag this and make a picture. So it's like a screenshot. Although I guess I could download it too, but sure, I like screenshots, they're pretty nice. And we'll go ahead and save this. And then if I go back to this repo that I was working with earlier, there's a neat little trick that I like to use where I go and I create a new issue and I call this images. And then what I can do is I can actually just drop a screenshot in there. So if I go through here and I add this in and I can say functions overview, just name it something, although you don't have to name that, you don't have to name the image. I can go back here and look, we can just throw this into our repo, which is kind of neat, right? So that's useful, but even further, what's kind of useful, right? So that's neat that I was able to build that out. But I also can go back to this Collab Notebook here, and I could say, this is an exploration of functions, like that. And then I can actually just throw that in there. And so that's kind of a cool neat little trick you can do, is that you can build out, stuff inside of here. And I guess if I really wanted to be lazy, or make it a little bit cleaner or something, I could actually make a nested structure. So I could go here and I could do like functions overview or something like this. And then I could also like basically nest it. So if I want to make another text document and just say like, getting started with functions, I can build this out, and then this will hide. I can hide that, right? So kind of a neat little trick you can do with Collab that I use a lot. So again, I'll go through here. I'll say File, save a copy in GitHub. It'll ask me to unblock it again, and then we got functions. All right, scroll down to Python functions 923. All right, so next step here, let's start to build out a function in Python. As I mentioned before, a function's got input, unit of work, output. So let's just make one. So I'll just call this my function, like this. And the easiest possible way to build a function is that. It's actually one line of code, and we can take a look at it by doing this. We can say type my func, like that. And notice, there we go, that we can do this, type my function, right? So really simple function, but also does nothing. So we can even put a doc, maybe like a little note here that says this does nothing, right? So it's not really useful. A more useful function would be a function that maybe accepts something. And so I can build one that accepts something. So we'll say, accept, and it takes an X, and then we can actually print maybe like a statement that says this was passed in, and then I can go through and I can do the same F string that I did earlier. So how do I call it? I just go through here and I say accept, and we put in hello. There we go. This was passed in hello. So this is also a reasonably useful concept to be aware of, is that you can build a structure that will hold some logic and you can just do something with it. So that would be reasonably useful function is something that you just put logic together and execute it. So we can even make a note here that says function that takes input, right? So that's an example. And what about if we want to build a function that it takes input and then returns something, right? Because if I assign this to a variable, I just say var equals accept hello, notice that it will actually be empty. So if I say type var, none type. So basically, it's not, by default, a Python function will just return back an empty thing. And so one of the things that we can do is we can actually make this a little bit more useful by making it actually return something. And so if I go and I add another text block here, we can say 1, 2, 3, function that returns values. There we go. And let's go ahead and make something that says maybe like more, and we can accept an X, and we could still pass in something, right? So I could just copy this print statement like this, and then I also could return something, and we could say return X plus 1. And so if I call this, I can do a piece of code and I can say more X. And if I just run this, whoops, I don't want to do X. More, we'll just put 2. It'll say this was passed in. So it passed in 2. And notice that the Collab environment is kind of nifty. It'll just like automatically show you what was returned. Regular Python code doesn't do that. But what I can do is I can actually grab the value and I can say results is equal to more and put 2. And now it says that the result was here. And if I look at the type of what was passed in, it's an integer, right? And then what is it? If I go to result, it's 3. So this is kind of the building block. Returning value is probably the most useful way to use a function, and how almost everything useful works. I mean, sometimes you'll write functions that don't return things, but in general, that style of accept things, do something, return things is really kind of the way to go. So, what else can you do with a function here? Well, I think one of the more classic things that people will do with a function, in my opinion, is more of a complete example, would be to add things, right? So you can accept more than one value in a function as well. So you can say X and Y, and then you can say return, X plus Y, and then I can add things together, right? This is kind of the classic, the classic way to use a function. And what's cool about this is that I don't have to change around logic or, do different things. I don't have to change my code. I can just use it over and over and over and over and over again because of the fact that it again accepts something and then it does something and then returns back the result. And this is probably the most succinct example of something like this. So let's do a little bit more though than just this. Well, another thing you can do with a function is that you can also pass in keyword arguments. So one problem with this is that these are positional arguments. So for example, if I make it a little bit more complex and I say add more or something like this, and we do X and a Y, and let's say that it also needed to print, and I said, this variable is greater than the other variable, right? And let's say that I was making explicit, assumptions about my code, and I could put in X here, and then I could say Y. And so I'm kind of hard coding some logic inside of here, and then I later, return back, X plus Y. Well, what would happen in this example is if I said add more, and I did, 1 and 1, it says this variable 1 is greater than the other, or actually, let's do this. Let's do 2 and 1. So I could say this variable is greater than the other variable. Okay, well, in that particular scenario, it's true. But what if I swap things around and in fact, I make X is equal to 2, and then Y is equal to 1, and then I say add more, and I put in an X and I put in a Y, that, whoops, let's put those on separate lines. If I go ahead and I do that particular situation is correct, but what if I accidentally swap it around and I say add more and I put in Y and X and I swap the order around? Well, 1 is not greater than 2, right? So basically it's positionally dependent in order to do certain things. And so this is a little bit problematic because in some scenarios it works well, but it's in other scenarios it can be brittle depending on what it is you're building. So what could you do? So what are the solutions for this? Well, you could also start to use keyword arguments. So we can actually maybe do this. Let's add a little section here that says 1, 2, 3, 4, Python positional arguments, Python function positional arguments like that. And let's also add a section down here, and we'll say Python keyword arguments. And so in this scenario, what we can do is we can actually fix that problem. And so the way we can fix that problem is that we can build something kind of similar. So we can say def add keyword, and we can say x is equal to 1, y, or x is equal to 2, and y is equal to 1, and just literally just copy that logic back into this. So we can just do this, and this is now robust against the positional ordering. So if I go through here and I say add keyword, or add keyword like this, and I just call it, first of all, it will remember these defaults, so it's easier to use, which is kind of nice. But also, if I went through and I swapped things around and I said, y is equal to, or in this case, I could even take those other variables, because remember, I defined them up here. Let's actually bring these down and just re-implement them, just so it's easy to see what's going on. But basically, now if I swap those around, guess what? It actually doesn't change things around, because we're able to actually fix things. So basically, in this particular example, it says this variable x is greater than other variables, and we want to do this variable 1 is greater than. So we want to actually say y is equal to 1 and x is equal to 2. Let's just kind of get rid of this. This variable 2 is greater. It was remembering the old keyword argument, but basically the positional arguments, because they're swapped around, are still, this statement still holds true. So that's really the big takeaway, is if you do the keyword arguments here, that you're able to actually kind of break a little bit of that brittleness of the positional aspects of your code. So I like to use the keyword arguments. I think keyword arguments are a great way to handle things, although you do have to be careful if it remembers a default like we just saw. But in general, it's a much more robust way to do things. So what else can we do though with functions? I think another thing that's pretty useful, and I think someone already mentioned this, was we can actually build a decorator. So let's actually build that out next here. So we'll say Python decorators. And what is great about a decorator is that it is a way of handling a lot of really cool things inside of Python projects. So let me just grab one real quick and grab a decorator. All right. Okay. Just give me 1 second here. But basically the decorator syntax is that you put this special, you put a special, essentially like an @ symbol on top, and then by putting that @ symbol inside, you're able to do fancier things to a particular function. And in particular, let's do this really quick here. Here's a good example of it. Would be that I can actually, or maybe actually a better place to start would be to do this. Let's go through here. Python decorators and generators. And what I can do is just throw this in. So here's an example of a slightly more complex function here. And notice that I have a function that doesn't accept anything. It uses a random import, and then it has some variables built into it. And then what I do is I say, while true, randomly pick a list of attacks and yield this. And so if I go ahead and I run this, what I can do next here is I can actually use a generator expression because this yield statement says only consume one thing at a time. And so if I go through here and I say next, we can see that I can actually just keep doing this. It'll randomly show me some things forever because I'm using a while true, and I'm able to yield back a result. So this is really a way of like kind of making an infinite loop that's controllable because it lazily returns back the results. And you could actually build this into maybe like a pipeline. And so if I wanted to build, let's put a little text box here and say, build a pipeline. You could actually do this. And here's an example where if I make a line of code below here, that it actually shows me, like essentially like a whole series of different random occurrences. So with just a little bit of code in this particular function here, notice all the magic stuff that's happening is because I say while true, it really is running infinitely. Because I'm able to select random, it's able to randomly select things from here. Because I'm using, this is called a generator expression, which is similar to a list comprehension, it's able to kind of go through this loop and efficiently, handle things. So why would you use one of these? This is a particular generator, is that it's a great way to handle infinite streams of data, which is something that happens a lot in cloud computing. So we'll just put a note here that says deals with infinite data streams. And so now, could we use a decorator to do a little bit more tricky stuff here? We could. And so one of the ways that we could do a decorator would be to maybe look at other things that are happening, or you maybe print it out. And in particular here, let me find an example of a good decorator. Is if you go to decorator function decorator, I think I have a good example inside of here, which is, let's see here. Just give me 1 second to find this other decorator example that I have. Yeah, here we go. So in particular, let's add a decorator down at the bottom here, and we'll say text, we'll say 1, 2, 3, 4 decorator. And if I want to kind of use that same style that I was using earlier, I can do this, right? I can say randomize speed attack decorator. And so what this could do is, to that other function that I had earlier, we could engulf that function, inject some things inside of it, and then return it back out. That's really the concept of a decorator. It's like a big fish swallows a smaller fish and then returns back the results. So what we can do is we can build something similar to what we had before. And here's the first thing. So we kind of tee up this decorator, and then we have one more code block. And look, all I do to call it is I say at right here, and I put the name of that decorator, right? So it does this. It calls this thing, and this decorator engulfs the whole thing. And so now if I run this, in order to run it, it'll actually inject random sleeps inside. So this would be kind of cool if you're going to build like a video game or something like this, right? Where I go through here and I say, okay, we're attacking randomly, after 1, 2 seconds here. And so this is what's kind of cool about a decorator is you can use it to control the behavior of other functions. And that's why we see them a lot in things like command line tool framework, web framework. And that's really the best way to think about a decorator is it grabs something, engulfs it, does some stuff to it, and then returns back those values. Now, that's a reasonably complex decorator. And let me actually just check this in so other people can get a copy of it. But let's actually use a much simpler decorator to explore the concept a little bit more. So I'm going to go through here and go to this right here. Perfect. Now let's make a much more straightforward decorator. And how would we do this? So let's do a little text block here and say 1, 2, 3, 4. A simple decorator, simple timing decorator. And with this one, we can see how it works. So first up, what you do is, I think is typically a good idea to use this library called functools. And this is built into the standard library in Python. And the reason to do this is that if you wrap it with this, syntax, it will preserve the outer name of the function. So a lot of times, one of the best ways to get started with building decorators in Python is to build like instrumentation, logging, monitoring type decorators, right? Because again, remember the decorator is a big fish that eats the smaller fish, right? And so this thing, what we're gonna do is we're gonna accept a function, which would be this f. We're gonna use this wraps library, so it'll retain all of the information about the function that was engulfed. And then we're going to also accept all the arguments and keyword arguments. And we're just going to time what's going on in here. And we're going to print this diagnostic statement. So what this diagnostic statement does is it says what the name of the function is, what arguments were passed in, what keyword arguments were passed in, and also how long it took to execute the function. So let's build a function that we can actually wrap with this. So a good one would be the add function again. So let's go through here and we'll just say add x and y, and we can say return x plus y. Right. So if we just run this, obviously pretty simple. 1 and 1 is 2, right? But what happens if we wrap that function with the decorator? So let's go ahead and do that. So let's make another one. Let's say def, we'll say at timing, and then we'll say def add, and we'll do x and y, and then we'll say return x plus y, and then what happens? So what this does is it's going to give us some additional diagnostic information. We'll say 2 and 2. There we go. So not only does it do what it was doing previously, but it prints out the name of the function is called add, the arguments that are passed in, 2 and 2 is passed in, and it shows that it took, in scientific notation, this amount of seconds. So kind of a cool little trick here that it's able to show us all that stuff. And I guess I could kind of convert this as well. Like, let's see here. What if we said float? Let's try that. Let's try. If I said, will this work? Float. Let's see if that will make it a little bit cleaner. So if I run this again, and then I run this, there. No, it didn't. It didn't change it. But I mean, you could figure out a way to. I think there's a formatting method in F strings that escapes me at the top of my head. But basically, you can keep tweaking this, right? You can say like, function name, right? And you could say like, debug, right? And you could go through here and put things inside of here, go through, add the function, and then you can add things together. So my opinion, this style is the best possible style to build things. And so if we go through again, how to understand functions is that whenever you define a decorator, the decorator is the outside function, so it's the big fish. And when you put it on top of another function, like a very simple function, notice what happens here is that this is actually the path that things go through. The function gets passed in, and it comes through here, does all of its work, and then it returns back a result. So let's start with maybe a little bit of theory here, just based on some of the questions that I got. And so one of the things was, with a function is, which one is which with a decorator. But so a thing to remember about Python functions, and we'll just go here and we'll have this Python function, is that you can actually have a function that can accept another function, right? So you can actually pass in a function into another Python function, and not only that, but your function can return a function in Python. And so that's one of the cool things about functions, is you can kind of throw them around almost like a baseball or something, where basically it comes into the function, you do some stuff, and then it can return one back out again. And so we were talking about this earlier. If we're talking about a giant fish here, maybe this is like a hungry fish that wants to eat another function. So if you do feed it like the little fish, right? So who would be who? Well, the big fish here would be a decorator, right? And so a decorator in Python is able to slurp in a smaller function, and then it's able to kind of emit it out. So it will be, I guess, an analogy would be it grabs this little fish and kind of tastes it a little bit. It's like, I wonder if I should eat this smaller fish, and then it spits it back out again and says, hey, I don't want this fish anymore. And maybe it, like, I don't know, it's got like slime on it or something. It's like a slimy, it slightly tweaks the thing that it consumed. So that might be a good way to think about it, is the decorator eats a smaller fish, tries it out a little bit, changes it a little bit, adds a little bit of fish saliva or something, and spits it back out again. And that's kind of the concept of a decorator, is that it's mutating the behavior of things. And you'll see the decorators a lot with web frameworks. And this is where you see them, is that with a web framework, what'll happen is you'll have a function that, again, does an adding, like, okay, we're going to add two things together, and then on top of it you'll do an at, and there'll be some kind of a route which will go to a URL, maybe that says add, and then that actually is how you dispatch things in a web framework. So they're really useful and used all over the place. And I think the big takeaway here is that functions can be passed in, they can be passed out, and also they can consume other things. So let's get into how to actually get a little deeper into them. And so I'm going to add a text box here that says how decorators, how closures work, which I think is a good way to explain this concept. And so let's just take a look real quick at making a couple functions. So if I just say a function here that returns back 1, and then let's make an outer function, and what we could do is inside of here we could return 1, right? So basically, I could, if I say outer, like, and I say like results, and if I say type, look, it's returning back a function. So basically, I can grab some other function. It's probably a little bit cleaner to explicitly, pass it in or whatever. But basically, look, I can actually take one function and take another one and throw it out. Now, now that I've assigned it to a variable, look, I can just do this, result. There we go. And we can see that I can actually kind of slurp it in, do something with it, and actually return it back. Now, to make things a little more explicit though, we should actually look at an actual closure example here. And so let me grab one here and throw this in. So just give me a second. And I'll grab this example. So we'll put a document here that says text, and we'll say, you know, how closure works, like that. And I'm going to take this. Now I'm going to throw this example in. So here's an example of this is obviously a very, very simple example of returning a function. But in this example, what I do is I have a function on the outer side here that accepts nothing, right? It's just a holder. And then the first thing that I do is I have two variables assigned. I have lower body counter and I have upper body counter. So these are basically just empty variables that are initialized. And notice that you can nest a function in another function like this, right? And inside of this function, in fact, before we even get into this, let me just do that. Let's just make a really simple example here, and we'll just say maybe like nested function. And inside of here, I can say def, outer, and then inside of here, I can say def inner, and then I can say return I was inside, right? And then what we can do is I can return back the inner function, right? So that's essentially the concept. It's like nesting things together. And then if I want to go through here and I want to call this, I can say result is equal to outer, right? And if I say type, it should show that it's a function that gets returned, right? And then I go through here and I want to now call that function. All I got to do is take the result and call it I was inside, right? So that's really the concept, just nesting things together. So if we want to go into a more detailed example of this though, I then take and I build actually a function that does a little bit more stuff. And this example is that it's a nested inner function that can explicitly only hop one level up. So if you use this word non-local, it kind of pops one step up, and now it can actually refer to that variable that's inside of the parent function. And now what I do is I have something similar. I have a dictionary, which we had just previously talked about, and I say if the particular dictionary is in the attacks, like basically if it's an upper body attack, I want you to increment this counter. And if it's a lower body attack, I want to increment the counter. And then notice that I just return back this inner function. So again, very, very similar to this, except for it's a little bit more complex and that it can mutate one layer above, right? Now, if I put those variables here, it wouldn't mutate them. It would only mutate this. So if I run this, then I want to see how it works. I would basically tee it up. So I would build a code example here like this, fight, do an attack counter, right? And then I just need to put in some variables. So first let's look at the type again. What is this, right? It's a function, right? So it's that inner function that's got all kinds of stuff in it now, and it's got some superpowers. And so now if I go through here and I say fight and I put in a word that it knows about, like in this case it would be Kimura, right? Because this inner function can accept it accepts arguments, and I say Kimura like that. Notice it says upper body attack 1. What happens if I run it again? If I run it again, upper body attack 2. If I run it again, upper body attack 3. What if I use a different lower body attack, like knee bar right here? There we go. So we say fight, what was it? Knee bar. There we go. Now it's upper body attack 3, lower body attack 1. So the closure itself is really kind of a cool thing to be aware of, because it can do these kind of patterns. Like if you were going to build a video game, for example, from scratch in Python, here we go. This would be kind of a cool way to do it, right? Like you had some kind of a character that was going to, you know, have special powers or attack or whatever, and you wanted to keep track of things. You could actually build a closure that was able to be called over and over and over again. And during the runtime of the game, it would keep track of the state of the world, right? And so it's a kind of a cool example of how that would work. And again, it's pretty simple. It's just an outer function that has an inner function, and then you return back the inner function. So that's kind of a closure in a nutshell. And that's why it's very related to this example of this decorator. So what's happening? Same thing. You have an outer function that is able to have an inner function inside. The big difference here is that it slurps in not just a variable, but it slurps in an entire function, mutates it, does some stuff to it, and then spits it back out again and returns it back. So that's really why decorators work and why they're so powerful. And I think that this concept right here as well shows you a little bit of how it actually works in practice. So let me go ahead and just save that so that other people can play around with it, and which is always, I think, one of the best ways to learn how something works. So I'm going to go through here, and I'm going to save this into Python functions. Yeah, and then probably the last thing that I'll bring up here, and I'll just collapse this, is that I think another question that people have is, what about those wildcard variables with a function? So let's go ahead and take a look at this, and we'll just say like, you know, wildcard variables for functions. And so let's take a look. Let's just say def add, and we can just do this. Asterisk args, right? Or no, let's just say asterisk args. It's going to be easier. And then I can say for arg in args, you know, I don't know. Let's actually make this simpler. Let's just say output for arg in args, print args, print arg. So if I call output and I just say 1, it's going to give me 1. If I call output and I call it with more than 1, what's it going to do? It's going to say 1, 2. If I call output with 1, 2, 3, right, it's going to do that. So, and to make it even more clear, I can even do this. I can just say, like, you know, you passed in this many items to the function. And then what we can do is we can just say len of args, like that. So let's do that. You passed in 1. You passed in 2. You passed in 3. Right? So that's really the concept with the wildcard, is it lets you dynamically pass in arguments into a function, which, you know, depending on what you're doing, like for example, decorators, this works pretty well. And also you can do the same thing for a keyword, right? So if I just say, you know, more or something like this, and I do asterisk asterisk keyword args, we can say, like, you know, again, maybe even just copy this. You can do this, pass this in, and we can just say keyword args, and then I could say for key value in keyword args dot items, we could just like print the key and print the key here, and even put this is the key and do that. Say key, and then we could do another one that said print f string, this is the value, like that value. Okay, and now if I call more and I put in 1 is equal to 1, let's see what happens. You passed in this many items. This is the 1. This is the key is 1. The value is 1. So, but now let's put more things in, and let's do this. Let's just say more 1 and 1. 2 is equal to 2. 3 is equal to 3. Right. So this concept of allowing dynamic arguments and dynamic keyword arguments is fundamental to doing a lot of the real fancy stuff like closures, decorators, and all this stuff. And so it is fun to use. I think it's good to be careful of getting too fancy in most of your code, but in certain situations, this really can be a pretty useful practice. So let's go ahead and put this into GitHub so other people can enjoy this fun. And again, it's a great way to play around with things. My recommendation is just keep playing around with this, and that's the best way to learn. But let's shift gears now, because we've basically mastered very quickly the functions, statements, at least enough to be dangerous. And now what we can do is start to get in building stuff with it. And so what I would do next here is that I'm going to go to GitHub, and I'm going to go to this repo, and I'm going to take a look at it and say, okay, great, we got this thing, we got a notebook inside of here, and you can even do this, which is kind of a neat thing to do. Sometimes when I'm building out things is, say like there's an overview, and so like this repo contains the following, right? And I could say like Collab Notebook explaining functions and statements like that, and I can just put a little syntax here that says this. Once I've got this cooking here, then I'm ready to start building out more things. And so what I would recommend to start with is to use this really cool tool called Codespaces, which is included if you have the Pro account. And so I'm going to click on Codespaces, and we'll say, yeah, I want to do cloud-based editing. Awesome. Let's go ahead and click up Codespaces. And then it just opens it up. I really am a huge fan of the web-based development. You can see I just did it with Collab. Now I'm going to do it with Codespaces. There we go. So we're using basically Visual Studio Code, and we're doing all kinds of cool stuff inside of here. And so let's see, let's choose the look. We can do all kinds of cool stuff inside of here. It's giving me instructions on what to do. Let's click on that. Okay. And then we can also say mark as done. It gives us a whole list of different things that you can do. But basically, I don't need to do that because I already know how it works. What I'm going to do first here, and even open it one more time, which is, let's just refresh, and we'll say file new terminal, or run, go to view file. I shouldn't have closed that terminal because terminal, there we go, new terminal. Okay, we got the new terminal here. The first thing that I would do is I would create a virtual environment inside of this editor. So I'm going to say virtual env tilde dot venv. I like to do this to create a invisible
hidden directory that has my Python libraries inside. I do v bin activate. So this is, and I even can put history here together, and I could even put this in the README. So that's why the README is so important. And I could even put like, okay, building code. This is what we do. And then I could say step 1 would be do this, and I could look at my history, and it could basically give me all the steps here, which is pretty cool. So there we go, and we can just put this in there. And so, first create and source a virtual environment. So libraries are easy to use, right? Because typically all kinds of problems happen if you don't use a Python virtual environment, because the system Python has different things installed, and all. Typically it's just a cleaner way to get started here. So once I do this, what I typically like to do next is just create a scaffolding really quick. So just create like a basic structure for my project. And so what we can do is just say touch a makefile, and then touch like a hello.py file, make a requirements file. And that's really kind of the basic scaffolding that I put on a lot of projects. And the reason I do this is so that if I go here and I install some kind of testing code like PyLint, for example, maybe even Black, which is a formatting tool, and then maybe, I don't know, PyTest or something, this is a good place to start. And then I might even want to play around a little bit with a command line tool framework like Click. So here we go. We got like a few tools here. These look ready to go. And then how do I install the software and do it in a clean way? Well, I can just go to this other repo here called Function Bike Writer. I'll even reference it as well. I'll just put a link to it inside of this repo in the README and just say like, you can refer here for ideas, right? And just go like this. And this links to this repo. And then what I can do is actually just start to check this in live so people can get access to it. So I can say get status, right? We see it's a README, a makefile, hello file, requirements. Okay, let's do get add star. There we go. Commit this, adding basic scaffold. And then if I say get push, what's cool is that this repo has got more stuff. There we go. We got more stuff inside of here, right? We have a hello file. There's nothing's inside of it. We have a requirements file that's got a few things. And then again, why I went to this other repo is if we go to makefile, I can just kind of copy this stuff. So let's copy it and throw it into this makefile. There we go. And so why do I do a makefile? To me, this is a really fundamental part of software engineering is you put a series of steps together, right? Install, test, lint. These are typical. So I can just say, for example, make install, and it will go through and it will upgrade the Python packaging tool if it needs to be upgraded, and it will install the software that I need to be installed. And then it's pretty easy to start playing around with my code. So if I go to this hello file, notice now we've got this nice IDE. It can do debugging. It can do all kinds of cool stuff. So let's build that add function again. So if I say def add, right, we can have an X and a Y, and we can say return X plus Y. And then from here, I can just call it. I can just say prints X and Y. Or I'm sorry, 1 and 1. Print 1 and 1 with add inside like this. And there we go. And notice how it even is able to like give me all kinds of really cool things like syntax highlighting and everything. So if I go through here and I say Python hello, there you go. So we see that it works. If you want to make it really fancy, what you can do as well is you can actually add a Python shebang line. So you say pound exclamation points user bin env Python, like that, right? And then now if I just make it executable. So if I say chmod plus x, I could do /, right? And now it'll actually print it out. So really that's the basics of getting started. So what if I want to write a test function to test the logic? Pretty easy to do as well. We can make a test file. We can say touch test hello like this. And then inside of here, I just call that other function by importing it. So I say from hello import add. And then notice that, look, it is able to kind of dynamically figure out if that's good or not, which is pretty nice. And then I can say test add, and I can just say assert, which is really nice about the PyTest framework to validate something, is just do assert that this thing is able to work with this other thing. So if I go through here and I say assert that 2 is equal to adding 1 and 1 together, this should be valid. And if I say make test, it says, uh-oh, it didn't recognize something. So let's go ahead and take a look at this hello, or take a look at this makefile. It says Python, PyTest, coverage. Oh, so I didn't install the coverage tool. So let's go ahead and do that. So let's go to here and we'll say PyCover, or it's like, I think it's called, well, we can look at the other repo here, which is this one, function bike rider. And let's look at the requirements file. Yeah, there you go, PyTest cov. Let's go ahead and do that. And let's put this inside of here. And again, this is what's kind of neat, is that it's pretty easy to install new software. I just say make install, and it goes through and installs it. And then we can go through here and say make test, and boom, there we go. So I've even shows me how much of my logic in my application is working. So this, in my opinion, is pretty much how you should create all Python projects, so that you have, a really good process for building software. And so this is really the foundations of DevOps. This is called local continuous integration. And from here, again, I can say get status, add all the stuff in, and I can just say star because I have a get ignore. I can just say throw it all in there. So get add star, get commit, adding the code to the repo. Now this is pretty good, right? And again, if I go back to this thing, it's got some cool stuff inside of here. We've got all this, but how does someone really know that my code actually works? This is a problem. I think that many people just don't do this. It's amazing how many people will create projects where their code, you really, if you pull it out of a repo, it's like, do you even know if it even works? And this is something that I think is important to master, is how do we actually tell other people that my code works? What is the process to do that? Well, what we can do is actually fix this by adding a build process. So adding a build server to it. And this is really the foundations of DevOps, is to always have some kind of build process that does the things that I did locally, and other people can see, what those changes are. So what we can do is really easily integrate this by using something called actions. So I'm going to click on actions, and there's a bunch of different things you can do. You can deploy to Azure, Cloud, etc., Google Cloud. We're just going to make one really quick. And I'm also going to be lazy, and I'm going to copy what I did in a previous project. So you can see that this .github workflows here is where you would do, basically your steps. Again, the local steps that I already did. So I'll go ahead and grab those, and we'll throw them in. So we'll go to this, go back again to my GitHub Actions. Where is this? Here we go. GitHub Actions. Dump that in. Now notice the steps here. It just says test my code, run it on this operating system, set up Python 3.8, install dependencies, make install, make lint, make test. So my opinion for writing logic, especially if you're using an environment like, Codespaces or Cloud9 or one of these other cloud environments, is that you're automatically testing your code and logic. It's so simple to do. It just takes minutes to do. You should do this for every project you work on. And if we go through here, we say commit, we can look at it and we can see that in fact, yes, it does work by validating the build process. And if we go through here, we should see this. Let's watch it build our code. Here we go. It's going to run the checkout. It's going to set up the Python. Installing dependencies. It says no rule to make target install stop. So we got something wrong with our code, which is kind of interesting. Let's double check what's in this GitHub Actions and let's debug it. So we have make install, make lint, make test. If I go back here, install, that does seem like it should work. Let's do a git pull. And then we can say sure, that looks good. And then we can do git status here and just push this code again. Let's see if that fixes it. So we can go back to our project and look at it, merging the branch. Maybe there are some pieces that weren't fully pushed. Okay, setting up the job, doing it again. Okay, there we go. So we got everything working. I think the make file was not fully pushed or something like that. There we go, install dependencies, linting, testing. So what's cool about this is I can go here, create status badge, copy it, and then put it into this project, and other people can see that, you know, my project actually works. Now, if we want to fail it, we can easily fail the build by a couple different ways we could do this. We could break it here. Let's actually break it by going to this hello file, and let's just put some. Let's put like let's actually make it subtract instead of add. So if I subtract instead of add, that doesn't syntactically cause a problem, but it causes a logic problem. And so our test should fail, not the lint. So if I click on this and we go through here, you should be able to see that the code will not fail at the lint, it'll fail at the test. Lint passes, we've got a problem at the test because we're actually subtracting, right? We're not adding, right? So that's really the advantage of doing this, is it can help you kind of protect your code from logic. So a really easy fix here would be to go back and fix that file. Again, I can just edit it right here. But that actually is in an essence the power of when you are building microservices, command line tools, is just get the scaffolding. It's pretty easy to do. Just get it done. So let's move to the next step though, and let's build a command line tool. Now to build a command line tool, pretty straightforward. I can again go to this other project here, this function bike router project, and kind of steal some examples. So here was a hello command line tool. Let's build this one, hello CLI. Here we go. So I'm just going to grab some of this code and just steal it, go back to my project here, and build this out. So there's a couple different styles to think about. Like, you know, one of the styles to think about would be that I could leave the logic in a library file. Another one is I could put it all into one. I kind of like the idea of leaving it in a library file and then have a separate file that's a command line tool file. So let's do that. Let's just build one called cli.py like that. And then let's paste in this other code example, which is right here. And notice what we do here is I say import click. It says click couldn't be resolved. Now, the reason why it can't resolve, I believe, is we may not have installed it. No, we installed it, so that should work. Or sometimes the editor itself is not fancy enough to import certain libraries. But what we can do is we can say from hello import add, and we can just tweak this function a little bit So we can say, instead here of name, we can say option would be first, and then we can add another one that says second right here. So let's just do this, first, second. We'll pass in first and second using, again, the same kind of stuff we've been doing earlier. And this would be add, and this would be add the first one, and then we would add the second one together. And then we can get rid of all that. We don't need this, but we can just echo out the results here. Oh, Vim doesn't, style isn't set yet, but we can basically say call add. There we go, call add. So all I'm doing is I'm using this decorator type framework, which is click, to engulf, which is what we talked about earlier, engulf some code. And in fact, this is better PEP8 compatible here. Let's just do this. Let's do add, and we're basically accepting some parameters, and then we're gonna click this out. I should be able to chmod this like that, which will make it executable. And if I do ./CLI and I say --help, what does it tell me? Okay, so it says first and second. In fact, I can just add a little documentation in here for other people by adding triple quotes and say this adds two numbers together. Right? Now I can do help again. Look, it says it adds two numbers together, and then I can just follow its instructions. So first we'll do 1 -- second will be 2. There we go. So it returns back 1 and 2, but the problem is that we're returning x plus y, which does look good. I don't know why it's returning back 1 and 2. It should be returning back results, printing results. So second, 2. Oh no, this is the result. Oh, but it also is not sure why that's doing that, but let's just do this for a second. Let's get rid of this, and let's just print the result. Let's keep it simple, and let's just do that. There we go. So it for some reason is printing out something else as well. Oh, because I know why. Because that's what was confusing me. Is like we have some rogue code here. I'm like, what? What is going on here? So we have a return x plus y, and then we can print this out, and we've got 1 and 2. So this doesn't seem right. We need to actually add these two together. So we need to say add first and second, and print it, return x plus y. Let's double check here. So return x plus y. Why is this doing that? Not 100% sure why this is not returning back. Why it's putting them together, but in a nutshell, I can fix that later. The main takeaway is we can write a test or whatever. Is that I'm able to get things wrapped up, put into a function. If I again say get, well, we could even do this. I could say pylints, right? And I could say make lints, and we could see is there some problem. Oh, it says no module named hello CLI, which does seem like that's a problem. So let's go through here. Let's change our lint, and we'll say hello, and we'll say CLI. So let's go ahead and fix that. And we can actually, we don't need this. We just need those two. And so we can actually say make lints. There we go. And we says unused import sys. We can fix that. So anyway, you can kind of debug your code, add tests, add logic. We could even write a test for this function. Again, we'll say make lint here. and get status, add all this together, and now we've got a command line tool that's working. And we can enhance it a little bit, adding CLI wrapper that's broken. Anyway, we can fix it later. But we got a command line tool working that should, in theory, we got a merge conflict here, which we got to fix as well. So we can just take that out, and we can take that out, and we can just say return. I guess we could be really explicit here, and I could say prints f. We could say this is X. This is how I would debug something. And then I could do another one that says prints this is Y. Go through here. And then I could say results is equal to I think it's an integer problem. int of X plus int of Y. I think I figured this out. And then we'll return back the result. That I believe will fix the problem. And so now, if I say CLI, that should fix this. There we go. So we got it fixed. It was because the click framework was converting it to a string. So we're able to, that's kind of a tricky problem, but get status, we were able to figure it out. Let's add the hello. Let's add the readme, and then commit, adding changes. There we go, push. Everything should be magically working. So we got a command line tool that does all kinds of cool stuff, and we're ready to go to phase 2. And I'm going to open up a console and get one of these things cranking. So here we go. We've got AWS. We got auth code. Here we go. Auth code here. 617. Okay. All right. So just like Codespaces, AWS has web-based development environment. You could do it in the console if you wanted to, right here with Cloud Shell, or you could also go to Cloud9. I personally like Cloud9 quite a bit, and here's actually a bunch of different environments that I had set up. Let's do it from the beginning though. Let's just create a new environment. I'll just call this function microservice, and we can take a look at this and kind of get this thing working. So next step, I would use all the defaults. I think that's the best way to get started. You can do all kinds of fancy things, but this is free, as I think we discussed earlier. Let's go next steps, create environment. Okay, and it just takes just a second to get things running. One thing actually, because this will take, let's say 10 seconds to set up, I'll just show you a really brief thing to point out is that since we are talking about functions, Lambda itself is probably one of the ideal scenarios to build functions out. And let's just build one really quick. So if I go author from scratch and we just call this hello, like hello, how about hello 9.3, 9.3 right here. You can actually choose runtimes, Python 3.9, let's use that, and create a function. And it's literally the same concepts that we've just been discussing. It takes stuff, does stuff, returns things. It can respond to events. And so once you understand the functions and the concept of functions, Lambda is really a dream environment. So I use it all the time. And here's an example. Let's clean this up a little bit. And I'm gonna do some stuff in here. I'm gonna do this. There we go. It looks good. I'm gonna say if the event name, let's just bring this here, name is equal to Marco, let's return back Polo, otherwise let's just return back no. This is kind of my hello world that I like to do, right? So pretty simple, right? There's an event that gets passed in. I'm going to introspect it because it's going to have a JSON payload, and I'm going to pull the key out, name. I'm going to look inside that key and see if it has the word Marco. If it does, I'll return back Polo. Otherwise, I'll return back no. And so here we go. Let's go ahead and click deploy. Once it's deployed, I can say test, and we can configure a test event, and we can say Marco here. And this is JSON, right? This is just a Python dictionary that's going to get converted into a JSON payload. And we're going to say here, we're going to say name, and we'll say Marco, like that. And if I go down here and I say format it, we can kind of clean it up a little bit, and then say create. And so again, notice it says looking for this key name if it matches this. So let's test it. There we go. We see it returns back Polo. What if I create a second test event and I make another payload? And this one will be like Bob. So if I put in Bob, this should return no, right? Because it's going to match on the name, and Bob won't match Marco. Format it, create it, test event. There we go, right? So that's it in a nutshell, how Lambda works. It's identical to how every other function in Python works. The big takeaway that's different with the AWS ecosystem is you can say add trigger here, and you can actually hook into a trigger and respond to, for example, web requests, IoT devices. You can do voice recognition systems. You can do all kinds of really cool stuff. Buckets, you could like do computer vision when you attach to a bucket. But in a nutshell, the Lambda system is very, very similar to regular Python functions. So if you understand Python functions, you can do things with Lambdas. So next up here, now that our environment is woken up, I can start to build out a microservice. So we see that you can do a lot of things on AWS, but what if we are able to deploy a microservice and do some really cool stuff with that? So what do? First up, I'm going to go to this repo, and I'm going to go and I'm going to click code here and go to local and look at this SSH key, SSH connection. And then I will actually move this next and try to clone it. What's going to happen is this won't work because I don't have SSH keys set up. You only have to do this once. Let's just do it. Let's get it over with. Like the first time you set up an environment, go here, TRSA. Let's just do that real quick. And then I can just print this out, right? So we can do here, we can just go like that, cat it, print out, boom, there we go. So now if I take this, I can go back to my GitHub profile, go to settings, go to GPG keys, say new SSH key, do that, and just say the Cloud9. There we go, Cloud9. Add it. Again, only one time you have to do this. Then if we go back here, we can go up arrow, right? Up arrow, down arrow, up arrow, clone it. We're into the functions. Now what I would do next here is just cd into this repo, and then I would create a Python virtual environment. Now notice if I just close this, we get all those goodies that I already created, right? Which is kind of cool. So I can now create a Python virtual environment by saying python 3-m venv /venv. Again, puts it in a visible home directory so that I don't have to mess with it and accidentally check it in somewhere. And now what I can do is I can source this. So I can say tilde.venv, bin activate. And if I'm really lazy, I could even put that into a bash RC and then use it every time I open up a new shell, which let's do that. Let's just be lazy. So if I go to history here, I can grab this command and I can actually edit the bash RC. Let's go ahead and do this, bash RC, and then I'll put this in at the bottom. And so all this does is that it means that the next time I open up a shell, notice that it sources this automatically, which is pretty cool. So if we go back to this environment here, I'm going to need to add some other tricks to get this code to work. And so what I'm going to need to add is I'm going to need to add FastAPI. And in fact, let's just even copy something that I was doing earlier which is, let's go here, and let's go to repositories, and let's just use something for speed. Let's use a FastAPI repo that I have set up, which is this FastAPI. So this FastAPI repo, I'm going to just copy some ideas from it. Let's see, first step, requirements. These are some, so I'm going to need to install this library and then this UVcorn. So let's grab those and put them into our environment. Let's see, we already have that. And then we don't need that, right? So we just need, these are the two libraries I installed, FastAPI. So I can say make install. And it's, again, going to work very, very similarly to what we did earlier with adding, except for in this case, I'm going to build a microservice as a website, and I'm going to add this together. So let's go ahead and do this and save this. Okay, save this. And now if I go back again to this project, let's just even grab the file here that does the magic, right? And let's take a look at this first before we grab it though. So I say from FastAPI, import FastAPI, import UVcorn, and all UVcorn does is that it's a web service that will run the code. I make an instance of the FastAPI library, and then look, now we get into the decorators again, right? So I say by passing in this parameter, it injects it inside and lets our code know that that's going to be the route that we're going to serve out traffic to. And then under this would let us do something a little bit more sophisticated, which would be to create URL parameters. So we can create a REST-based web service where we add two numbers together. And then right here, notice as well that I even can declare the types. So this does give us a little bit of extra capabilities by using this FastAPI service. It lets us actually do type checking, which will also come in handy when I show you how the API documentation works. And then again, I do the same thing, right? I say total is number 1 and 2, and then return this back out. There we go. We've got this thing. So I'm going to grab this and put this into a main file here. And so what I'll say is touch main.py. There we go. Perfect. We got this thing cooking. And now let's go here. Let's paste this inside. Okay, we got this running because all the libraries are working. So to really just get this working, all I need to do is just say Python main. And notice that, FastAPI is not working because I need to do a make install, because I put those in the requirements, but I didn't install it. Now I'm going to install it. All right, great. We got this thing cooking. Let's go ahead and do a Python main. There we go. So this is now running on external IP address actually of this machine, but also available via localhost. So how would I query this thing? Well, I would go here, I would say new terminal, and I would say curl 127.0.0.1 8080, like that. Okay, does this work? It does. It says hello Duke. Now let's go ahead and change this to hello O'Reilly, kind of mix it up. Now notice what happens as well is that it actually can dynamically reload, I believe. And so if we do it again, no, it doesn't dynamically reload because I didn't tell it to dynamically reload, but it can. There's an option that lets it dynamically reload. This is more of like production style here. But if I curl it again, there we go, hello O'Reilly, right? So we're able to expose this. Now, this is pretty useful that I can curl it like this, but one thing that is a little bit tricky is that I may want to look at the documentation. And so if I do curl docs, whoa, we see all this stuff, but I don't get to see it visually. So what can I do? Well, one of the things that we can do is we go back over to AWS and we can go to EC2 and we can find our Cloud9 instance. And in this case, there we go. Here's our Cloud9 instance. Let's make it a little bit better, right? This is the microservice that I'm building inside of the Cloud9 development environment. And it even shows me instance ID. If I click on this instance ID, it gives me a few takeaways. One, this is the public IP address right there. And so if I click on this, though, it's not going to work because the security hole is not open for us, like the port is not open for us. And so instead, again, I'll just try this. If I go through here and I say, 8080, it's not going to work. So I need to open this up to the outside world. In order to do that, I would go to the security group and I would click this button, security group. And then I would say edit inbound rules. And all we need to do is just add a new rule that says custom TCP port 8080, right? Which is where we're running. And then I need to change this to 000. And then say save rules. And now if I go back to this tab here where I had the the thing I was trying to run, it should work. But let's see here. Let's go back to this real quick. Let's go to the IP address. So the IP address is this one, 54.82.166.171. Let's go through here. Let's just put it in like this and say 8080. There we go. So we can see hello O'Reilly. And then if I want to go to docs, this is where all the cool stuff happens, is that we can actually start to use the FastAPI Swagger documentation, which is really in a sense, the gold standard for how a lot of people are doing API documentation. Now, check this out. If I click on Git, it'll let me try it out, which is really helpful because this will allow me to test my API endpoint. So if I go execute, there we go. And we can see that it actually tells me the response body, the content length, all this stuff right here. And then look at this curl command. If I copy this and I go back here, we can actually paste this inside and say curl -x git. It goes through, it does a get operation, and then it does a query. There we go. So what's cool about this is that I can even add this in as like maybe some instructions to another person that's using my web service. I can say, building microservices, building web-based microservice. I could say, go to external IP address with :8080 docs, query the add API routes. Like if I'm explaining to other developers in my company how to use this web service, and then maybe like note, you can also query via curl, because it will give you a curl command, right? And so I can even tell other developers, hey, check this out. You just do this curl command, and then it will query the service. So now I can even go into this Python functions, get status this, do get add all this in, commit this code. Let's go adding in examples, adding in Swagger, FastAPI example. There we go. And then this does happen a little bit. That's kind of annoying. The first time you set up Git in a new environment I think it's a good idea to, not use the defaults, and just use, so that way you keep track of your commits and you can look at really cool statistics and see how productive you are and all that kind of stuff. But let's go ahead and change this real quick. Go through here, and then we'll amend the commit so it'll fix that error. And we can say, there we go, we want to exit, save it, git push, there we go. So if I go back now to my other, if I go to my other code example here, which is going to be functions, there we go, Python functions course. And we look at this, we've got a main, right? Awesome, we've got all this stuff working. And then we also have the ability to to see how to curl it and all kinds of cool stuff, right? So I really do like the FastAPI web service. I think it's awesome. So this is one cool thing you can do is querying it, right? But what if I want to actually do a deploy? How would I actually do a deployment to this environment? Now, fortunately, let me actually just stop this thing since it's running. There we go. One of the things I can do to deploy it is use a platform as a service offering that is really kind of convenient for this. And so they have one on their platform called AWS App Runner. And App Runner, you can see here, is pretty slick because it really, you just hook up the source code and just deploys it. So let's go ahead and do that real quick. Let's go to create an App Runner service and go to source code repository. And what you'll notice is that it's pretty straightforward. So we go to source code repository. You would just connect your GitHub repo to it or your company's GitHub repo to it. Then we go to repository. We just got to find a list of places. We'll go through here and we'll say Python functions, which there we go. And then you pick which branch you want to deploy to. Now, just to be a little bit tricky here, we could actually mix things up and actually make another branch. And so this is just something to be aware of, is that you can go to view all branches and you could see the different branches here, right? And in a DevOps type work environment, you may want to have a main branch, a staging branch, and maybe a production branch. And so what we could do is we could actually say git branch -v, I think, right? Is it -v? Is that says show me what branch I'm on? And so I could say git checkout -b, and we could say staging, for example. What happens? There we go. We have a new branch called staging. And if I say git push origin stage, this should push all this to a new branch over here. So let's refresh this. There we go. So now we've got a staging branch, right? So we've got a staging branch. So if I go back here, I can kind of toggle between these two branches. And so again, imagine this is where I'm doing most of my development. I'm doing all kinds of cool stuff. And then I want to, show the product managers in my company how to do stuff, right? I could create a second branch that's like maybe a little bit behind all I'm doing. So that way the two things are not changed. We know that this branch works, and we can now kind of go to my next task and maybe even break the main branch. So what we can do then is we can go to App Runner here and we can say, hey, let's actually refresh this and let's see. Oh, there we go. Let's deploy the staging branch, right? And so I'm going to go to deploy the staging branch. I would recommend when you're first setting up a service like this to use manual to go through and pick this out. Let's go to manual. And now also I would recommend doing this manually to start with until you're comfortable. And this is pretty straightforward. We just say pip install, which we've been doing over and over again, requirements.txt. And then from here, we did this locally, right? You just say Python main.py, right? So just run that FastAPI service. Perfect. Next. Now for service name, we can just call this stage branch FastAPI. There we go. And you could tweak things here. You could add more virtual CPU, more memory. You could add environmental variables. Like if you need to talk to, let's say, there's several databases in your company. You have the development database where you're playing with non-personally identifiable information or non-PII. And then you have another one that's like the production database. And you may want to have different environmental variables for different databases. You could template this out as well, and like with infrastructure as code, but something like that I think is typical. And then we go to next here and we say source, do all this stuff, create and deploy. And then we've got this thing cooking. That's it. It's pretty simple. So it'll take, let's say, a few minutes or so to get this thing running. But what's cool about this is that you get this really awesome full end-to-end platform as a service offering that we're able to do a lot of stuff with. So since this will take about 5 minutes or so to fully deploy, let me actually just whiteboard this out. Let's actually kind of deploy, right all the things that we're doing and why they're important and all that stuff. So let's get into step one. Was, if you remember, we'll call this microservice. And so if you want to deploy a microservice in the DevOps way, there's a few different components you need, right? These are kind of the raw ingredients. Raw ingredient one is you're going to need a source, right? So we have the source code. In this case, we have GitHub. You could use any repo, management system, Bitbucket, whatever. Next up, you're going to need a build system. And so I think many people have talked about this. There's Jenkins, there's GitHub Actions, etc. In our particular example, App Runner itself has one built in. So we don't need to do anything. It actually is kind of got an implicit build runner built in. Also, we're going to need the logic, right? So we're going to need some kind of business logic. Also, in this case, it's such a simple function. We just put it inside, and this would be the add logic. We're going to need a framework. So we use the FastAPI framework that does all the magic. Now, what's cool about FastAPI is that it has type checking, which for the web services themselves, type checking is actually pretty cool because it really fits well with the way web services work. It also has Swagger, which is pretty cool, which is the API docs. And also the other thing about FastAPI is that it also allows you to minimize things, right? Is that you are able to minimize the stuff that you're doing. So once you've got these kind of raw ingredients working here, really the next step is going to be the environment that you deploy to. And so what about that? Where would you be developing your code? Now, we tried out GitHub Actions and Codespaces, which is pretty good. In our case, though, Cloud9 seems to be a little bit of a better fit. And the reason for this is that it runs in the same environment operating system as our deploy target. So this is really a key thing to be aware of, is when you are deploying your code to an environment, it's much better to really identify the environment that you're going to be deploying to and have a similar environment. If you're using OS 10 or Windows or something like that, it's possible, but it can be a lot more work. So why do that if you could just use your existing infrastructure? Finally, if we go into the target, right, this would be the target deploy environment. This is where we would use the deploy environment. This is where we would actually use App Runner. And so AWS App Runner here is able to actually be serving out the microservice and is able to actually do all of our work. So these are all of the core components. Really, I call this the 6 ingredients or the 6 elements to building out microservices. Now, notice as well that you can do machine learning with this. You can do software development services. You can do all kinds of stuff with this. But in general, these are the things to be aware of, that you need to have these in your toolkit: source code management, logic, build server, framework, environment, deploy target. Once you've got all this set up, you're good to go, right? You can actually go through and build out a successful microservice process. So that's the theory. Now let's go into the practice, and let's go ahead and test this thing out. If we go back to App Runner, it should be close. Let's take a look again. And yep, it's running. Now we just click on the button and it should work. There we go. Hello, O'Reilly. Awesome. And now this is an encrypted, end-to-end service. And let's look at this as well. If we go to logs here, you can actually go through here and check out all the logs as the service was created. You can also look at, that's the deployment logs. You can also look at the application logs, which would be the business logic. And look, there we go. We can see the application log working, and actually it'll show that whatever it is that's happening. I think if I refresh it, and I go back to this and I go, let's call some things. Let's say let's add 4 and 5. There we go, 9. And let's add, 5 and 10. So make 15. And so if we go back here, eventually these should show up. There we go, right? We see those logs actually populating. You also can go into CloudWatch and take a look at how CloudWatch is handling these. And the reason for this would be that you may want to do things like build a metrics filter or other things like that. And again, this is pretty cool, right? I can go through here and really query things, filter events, again, create a metric filter or something like this, and then build a dashboard, right? Application monitoring, traces, all kinds of really cool stuff that you can do that's pretty amazing. Like, for example, I want to see all the successful web requests. I want to see all the errors. I want to see a throttling, ton of different things inside of here. The service map, show me exactly how this whole thing works. I mean, there's a ton of stuff that you get for free that comes with the AWS CloudWatch environment. That's the logging. In terms of the configuration, you can also go through here and take a look at how the services map down here, right? You can see where the source code is, how it was tied into the repo, which branch as well. So if you had multiple environments, like a master branch, a main branch, etc., you would see all that going. So that might actually be a good next step here, is because I think a lot of times it's confusing for people. It's like, well, why would I have multiple branches? How would that work? So this is the staging branch. Well, now let's make a production branch, right? So let's make another service. We'll go here, source code. Now, we only have, if we remember correctly, we need to go back inside of here and let's also make a production branch. So let's do the same thing. We'll say get checkout production, just like that. And then we will push origin prod. There we go. Let's push that branch to prod. Let's take a look at these branches. If we refresh here, and we should see a production branch. There we go. We got a main branch, which is where I would do kind of the bleeding edge development. Maybe the staging branch would be where I give things to the product managers or QA to take a look at things. And then I have a production branch, which would be literally the service that is exposed to the end users or the customers, right? And so let's build another app runner service, but this time we'll talk to the production branch. So let's go down here. Let's build another one. There we go. Let's go to refresh this. We should see production. There we go, production branch. So pretty easy actually to set up this modern DevOps lifecycle using tools like this. We go to Python 3, do the same thing. We say pip install -r requirements .txt, and then we say start command, and we just say Python main.py. Boom, there we go. Let's say next, and then from here we can say production prod FastAPI. And then again, now you could also do maybe more advanced scaling for production because you want to have maybe higher concurrency. So these are things to just think about. Like, for example, if I want to add more requests or I want to add more instances or things like that, I could also do custom health checks. For example, how long do I want it to time out? These could be slightly different depending on, what you're doing in a production environment. But we'll go through here. We'll say next. We'll go and we'll create a deploy, and then there we go. Now we have two different branches for our service. So I've had many people ask me this, like, well, how do I do different deployments and how would that work? It's exactly like this. You create multiple branches using GitHub. You push those branches. You tie them up specifically to instances. If it's a really complex application, it could be a cluster of machines. If it's a microservice like this, it's pretty trivial, right? You just create a new instance, map it to a different branch. That's it, really. So this again would be, a great example of how to do, multiple processes for deploying multiple branches. So that'll again take a few seconds to get all that cooking. So I won't really wait for it. We don't really need to wait for it. So I'm going to clean up what I did. So first step, go here, delete this, just say delete. We don't need this anymore. And probably a good idea to always clean up your services if you're not in the habit of doing that. We might have to wait for this service to wake up, which is kind of annoying sometimes, and so you have to remember to come back for it. The other thing that I would clean up as well is clean up your environment so that you're not being charged. You could always leave a process running or something and forget about it. So what I will do as well is go to Cloud9, and I'll show you how to clean this up. So I think it was function, what is this thing called? Yeah, function microservice. We can click on this and we can just go here and just say delete. That's it. And then we can go through here and delete this. This isn't strictly necessary, but it can be a good idea to delete these things because they can get a little bit unwieldy. And also if you store things on the, you get charged for storage on AWS. But by default though, you should be fine with not worrying about these things. So I think that this looks good. We got this cleaned up. We got all of our resources cleaned up. I'll come back later and clean up other things. But that looks like a good wrap-up point to maybe summarize everything that we've done. So in a nutshell, let's go to the very beginning. What we covered today was really how to go from 0 to many different options with functions. And so, Python functions, what are the takeaways? So the main takeaway is that they are a unit of work, right? This is where the business logic is kept. And if you want to have an input, it will accept an input. In our case, we use the X and Y a lot, right? These would be representing two numbers. The work component, which is what we did a lot, was basically X plus Y. And then the return value was, in some cases, it was JSON, right? If we were doing a web service. Other cases, it was just a plain string, or it was a integer. But in general, the return value was the result of that work product, right? So this would be like the results is actually returned back. And so once you've got this style, that everything in Python can kind of fit this pattern. You can do a lot of stuff, and that's really what we got into. Is you can maybe kind of summarize this and say you can use Collab. That's a target. You can build scripts. That's a target. You can build command line tools, right? That's a target. You can build microservices. That's a target. We didn't really get into this too much, or even at all, but you can also build apply functions, for example. So you can apply a function to a vectorized method. So you can basically do GPU. You can do data frames, right? So you can take a function and essentially kind of map it row by row to a distributed computing problem and have massive parallelization by applying a function. So really, this is, I think, one of the most powerful things to master. Also concurrency. So a lot of problems map very well to concurrency. So for example, processes, threads, you again could just take a function, map it to a series of processes. So in my opinion, the Python functions is essentially solves 80% of all problems in Python. And in fact, the simpler you make them and the more you can kind of streamline things, you can master all these different techniques. Also, we got into more of the kind of like tactical Python, which would be the other things you can do. Tactical Python would be, you can do decorators, which are pretty cool. You can also do closures. You can do all these kind of generators, right? There's all these really cool things that you can do with Python functions. So again, my opinion is that this is probably the most productive place to be working out with Python, focusing all your time. Some of these more advanced topics of object-oriented programming, I think are theoretically interesting in certain scenarios, but they're more of the 20% edge case where I found the majority of like regular stuff that you do is a Python function, and that's where I would recommend spending the majority of your time.